Completing the square is quite useful when we're dealing with quadratics. If we can rearrange a quadratic equation to get into the form y equals ax take h all squared plus k, then from that we can state the vertex is hk. So completing the square can be really useful in getting it into that form. You can also solve an equation, so find its x-intercepts, a quadratic equation, if you've got it in the form 0 equals ax take h squared plus k, because we can then pop the k on the other side, get rid of the times a by dividing, get rid of the squared by square rooting, etc., and you can find the x-intercepts or the solutions to that quadratic. It's quite a simple process as long as you know how to expand perfect squares. So let's just remind you about that x plus 4 all squared, remember that is x plus 4 times x plus 4. You can't just say it's x squared plus 4 squared, because remember your FOIL steps, when you expand this x times x, we get x squared, we get a 4x, another 4x, so we end up with 8x. 4 times 4 is 16. And the thing to notice here is that this 8, let's change the color there, no, it won't change for me, this 8 is half of the 4. So if I had this expression to go from here to here, I need to divide by 2, and then this number here, the end number, that is equal to 4 squared. Okay, so if we know that, it's pretty simple to go backwards. So let's have a look at just one more. What if I had x squared take 14x? And you go, well, what's going to go in this bracket and what would have to go here? The key is that 14. So I know halve that gives me x take 7 all squared. And when I expand this, I'll get the x squared, I'll get the 14x, but over here, that would have to be 49. So keeping that in mind, let's do a question. We've got y equals x squared plus 6x take 2, and I say please find the vertex of that. What I need to do is pop it in this form. So the first thing I look at is this x squared plus 6x and go, yep, focus on the 6 there, because I know if I halve that, so I get x plus 3 squared, because I know that when I expand this, I'll get the x squared, yay, I'll get the 6x. I will also get a plus 9. So to make sure that this statement is true, I will then simply take 9. Okay, so x squared plus 6x plus 9, take 9, the 9's cancel, I've got this, and my minus 2 is still sitting there. So this allows me to then say this is x plus 3 squared take 11. Therefore, it's as easy now saying, well, therefore the vertex will be minus 3 minus 11. Keep, oops, reverse the sign, keep the sign. You could use the same system if it asked you to find the x-intercepts or the zero solutions roots of this equation, because you're then trying to solve 0 equals x squared plus 6x take 2. You've got options. You could try and factorize. Clearly you can't factorize this. To be honest with you, I would then go straight to the quad formula. However, if we look here at our completing the square, once again we're looking at the x plus 6 here, which means I can pop this into x plus 3 squared. How did I get the 3? Half of 6. And this time I changed my way of thinking and I said, okay, well, I want everything on the other side. So the minus 2 goes on the other side. And when I expand this, as we discussed before, I get x squared plus 6x plus 9. So I've technically added 9 to this side. So if I've added 9 to this side, I have to do the same to the other side, and I add 9 there. 9 plus 2 gives me 11. I've got x plus 3. You might think, I just want to do the same method as here, and then you can plop that minus 11 over the other side and you get the positive 11. So it's up to you which method works for you. We now want to solve, So to get rid of the squared, we have to square root. Remembering when we square root something, we can have a plus or minus answer. And this now leaves us just with x plus 3. To get rid of the plus 3, we take 3. Therefore, x will equal minus 3 plus or minus root 11. And those are your solution zeros or x-intercepts to that equation. So it just depends on what the question is asking you. Is it asking you for the vertex, or is it asking you to find the x-intercepts? Obviously, if you do this and this number here on the other side becomes a negative, then you haven't got any x-intercepts because you can't take the square root of a negative number. So just keep that in mind. Let's just do one more to make sure that you have got the hang of it, and maybe pause the video and you carry on to do it before I've done the solution. So let's take y equals x squared, take 7x, take 4, and we'll say let's find the vertex for this. So again, what are we looking at? We are focusing on this section here. That was a little bit too far there. So we want to focus just on this minus 7, and we know that that's a 1 there. Okay, so we halve it like we did before. We say that means x take, now you could say 3.5. I just like to say, yep, halve it. So when I expand this, I get the x squared, I get 2 lots of that, which is minus 7x. So what I've actually done is I've added on this squared. So I need to take that number, the 7 over 2, off squared, and then I've still got my take 4. Tidy things up, we get minus 7 over 2 squared. Remember, when you square a fraction, you square the top and the bottom, so that's minus 9 over 4, take 4. Just tidy this up, 49 over 4, take, will that be 16 over 4, so that becomes 65 over 4. Therefore, our vertex is 7 over 2. But we have to reverse the sign, right? So not minus becomes positive 7 over 2, and minus 65 over 4. And that is completing the square to help us find the vertex.